Okay, number 91. You've got a crate. It's 225 kilograms. So it's got a weight, if you take that times 9.8, 225 times 9.8 is 2205 newtons. Or probably 2210 is a better, but you know, that's okay. I'll round it off later. It's pushed horizontally with a force of 710. So, you know, usually people push it to the right because, you know, you read left to right, but I wrote that over there. It doesn't matter. 710 newtons. The coefficient of friction is 0.20. So the coefficient is 0.20. Calculate the acceleration of the crate. Now, I'm going to actually have to erase this because friction is over here, but I also have the normal force. And the normal force is 2205 because it's being supported. It's not going up in the... If you think about it, gravity's pulling it down, but the surface is lifting it up. And this crate doesn't float off into the sky or doesn't dive down into the ground. It stays on the surface. So these have to be the same. So to find the force of friction, you use the coefficient times the normal force. So you take 0.20 times 2205, and that will give you the force of friction. 0.2 times 2205. You get 441. Now, to figure out the acceleration, use F equals ma, but remember to use the net force. And the net force is 710. I'll say positive is this way, minus 441. The mass was 225, and the acceleration is unknown. So now I can solve for my acceleration. 710 minus 441 divided by 225 is 1.195, repeating, or 1.2. Let's see, how many significant figures do we have to have? Looks like everything. 3 of them, so probably 1.20. The book has 1.2. Why is that? Oh yeah, the coefficient of friction only has 2, so your answer can only have 2. 1.2 meters per second squared.